Right, good afternoon, everyone. It's a great pleasure to be here, as ever. I enjoyed the first two talks. They were great. Al's talk took me back in particular to, I had the misfortune to map Block 21 twice in the 90s. But because I was only a junior geologist acting under orders, I blame my management's lack of vision rather than my lack of expertise. Anyway, that's not here to talk about talk about Angola. I want to do two things. I want to show you a new product that we're about to launch called the Wildcat Data Base, and we're going to use that. It essentially covers 3,000 to 4,000 exploration wells drilled in the last 6 years, and I'm going to use that to explore the transform margin play, the Jubilee play, if you like, over the last 6 years. So what we're going to do is cover the database, show you a bit what that does, and then we're going to get into the Jubilee play itself, look at the results of exploration to date for Jubilee analogs, and ask the question of, we've calculated about $3 billion spent in exploring for Jubilee analogs since the Jubilee discovery outside of Ghana, and no commercial discoveries yet, no definitively commercial discoveries yet. So what's going on? What's needed to find another Jubilee? And then wrap it up with some conclusions. So firstly, on the database, what is it? There's an information layer, which is we collect exploration and appraisal wells, put them into a database, collect the basic sort of information around equity interests at the time of drilling, the country, basin, water depth, etc. And then we classify each well by play and prospect type and the primary target. And we collect as many maps, sections, images as we can from the public domain, or presentations that companies give to investors. We try and put them in one place and for posterity. We collect pre-drill information on unrisked volumes, whether if it could be the company's unrisked volumes or we'll assign our own. We give each prospect a chance of success and to enable us to predict or give a prediction of risked volumes. And then we look at the post-drill results for each well, look at the discovered volumes, for wells that fail to find commercial hydrocarbons, we'll do a failure analysis, and then we'll track the wells through the appraisal stage and update the discoveries. All the volumes we tend to assign to the discovery well rather than to subsequent appraisal, but it's all based on public domain information. There's an analysis. What we do, we use the database to do analysis on companies in terms of their peer performance, how are they doing, what's their exploration track record, looking at their drilling plans, looking forward, to able to do valuations of companies, to enable you to look at countries and basins, look at success rates, finding costs in different countries and basins. And at a prospect level, there are enough wells in the database now that we can actually use it to look at analogs for prospects. Prospects that targeted the same age play in the same basin, what are the volumes, success rates, etc. And the reason we're doing all this is to try and gain some insight into where are the growth opportunities of the future driven by conventional exploration, what are the successful exploration strategies, and hopefully to help get better prediction accuracy from exploration and higher exploration performance. So that's the database. So we're going to cut now to, this is, they say never work with children and animals. I would add the internet. So this is live on the web. So if it all crashes, then we'll have to go back to the hard copy. So this is the live database. This is the homepage, and this is showing at the moment in blue circles are wells currently drilling. The circles are proportional to the number of wells drilling in our database. And you see the big blue circle here is Iraqi Kurdistan. There's about 16 wells currently drilling in Iraqi Kurdistan as we speak. But we can also, on this map, we can display anything we want. We look at oil discoveries in 2013 and where of oil discoveries being made this year. And you can see Iraqi Kurdistan, surprise, surprise. Gulf of Mexico, particularly in the lower tertiary. Here, this is the Statoil discoveries in Newfoundland, Bay du Nord, etc. And this is the deep water. These are the recent discoveries that, two discoveries that Cobalt announced yesterday in the pre-salt, late last week in the pre-salt Angola. Now, we're going to focus on the transfer margin. So if we click on that bubble there, each bubble, that's Ghana this year. It's only been 2 oil discoveries this year, only 40 million barrels. And these are being made by Hess in the deep water there. But they're really quite small discoveries, and I guess they're going to be tied back into the Paradise discovery that was made previously. So it looks, when you look at that map, it's drying up a little bit on the transfer margin. So let's try and delve in a little bit deeper. So if we look at exploration wells drilled since 2008 and display them, and then zoom in a bit. So we can see in the transfer margin, most of the wells obviously in Ghana, and then it's spread through Cote d'Ivoire, Liberia, Sierra Leone, up into Guinea, and then across into French Guiana, Suriname, and Guyana. But this all started from the Jubilee discovery. So if we use the well search function just to look for Jubilee. By the way, I'm not doing this telepathically. I do have an assistant up in the... It's not that clever. I'm sure one day they'll invent something that can do that. So we can do a search, and we pick up the 2 Jubilee discoveries. So this is Mahogany 1. Let's click on Mahogany 1. And this is Mahogany 1. So we collect all the basic data, who were the partners at the time the well was drilled. And if we scroll down, we collect some images here. So this is the map at the time. This is before the well was drilled. You can see there were some discoveries on the shelf, but nothing in the deep water, just a few sort of blobs on a map. If we go close that, scroll down a bit, look at this one. This is the map. In 2006, I was at a conference where Brian Maxted, Cosmos, presented, and this was his slide justifying why they went into Ghana and the Tano Basin. And you can see this is the Eastern Tano Basin here, the March Fracture Zone. So what they were pointing out, this pink bit here is mature late Cretaceous source rock. This orange here is an input point for Upper Cretaceous sands into the margin, would deliver sands into the deep water, and the pink arrows are where the projected migration pathways, which are focusing oil in this area here of the Eastern Tano Basin. So Jubilee came in, and it was a fantastic success. Everyone got excited. If we go back up, go back up to do we'll just do a search for all the wells in Ghana. Let's see what we do. Yeah, click on that. What the database allows you to do is just look at exploration performance at a country level or at a company level. So we can search from, just putting in from 2007 to today. And we're going to show by basin, screen just the Ghana portion of this is the Ghana portion of the Tano Basin. There are 2 basins. So the 29 wells we've got in the database, 62% success rate, and 2.4 billion barrels of oil equivalent, of which about 75% is liquid. So a huge success story. Total gross well cost of 1.5 billion, so less than $1 a barrel. All very good news. So that set off a train of exploration to try and obviously replicate Jubilee elsewhere along what is known as the transform margin. So if we now do a well search for what we're going to do is by basin, we're just going to look at Sierra Leone. we're going to look at the wells that, yeah. We'll scroll down. This is there are about 11 wells now in the drilled in the Sierra Leone Liberia Basin. And it all started off with Venus 1. And we're going to home in on Venus 1 because I think it illustrates a lot of what was the problematic with the play. So this is Venus 1. This is the pre-drill image. And we're working off cartoons here. Unfortunately, we're outsiders, so we don't have access to the actual seismic. So we have to piece together the story from the cartoons. This is a cartoon that appeared in the 2009 Capital Markets Day presentation from Tullow. Anyway, this is the Venus well, and you can see the main target was in the Campanian. There is some kind of structure there, and then a deeper target in the Turonian. So if we close that and actually look at what they actually found, you can see that actually the Campanian, which was the main target where all the thick sand was, they found oil in thin sands at Turonian level. So it showed that it was rather difficult to predict. So where you were finding sand, thick sands, you weren't finding trapped hydrocarbons. And in the thinner bedded sands, you were finding some hydrocarbons, but not in commercial quantities. So if we now look at, let's go across to French Guyana. Because French Guyana is when the super majors started to get involved, and a well called Zadis was drilled, and it came in, finding light, well, a mixture of oil types, but it seemed like a positive discovery at the time. We still got it in as potentially commercial, 175 million barrels. But you can see the follow-up wells have all been unsuccessful. Zadis 2, Priodontis, Cebus all came in dry. Mainly, we attribute that to trap failure or a combination of migration and trap failure. So if we can go back to the slides now. Actually, just go back to that one slide. You go back to that one. Just back one. Yeah, that one. This was this is what Jubilee looked like. This was the pre-drill image from that Cosmos showed, and actually Paul Daly showed at a recent conference at Wembley, the recent Africa conference at Wembley. It's an important well to show because this is the amplitude anomaly here with a class 3 AVO switch off at here in green. But you can see the faulting mapped here. So right pre-drill, it was identified as a faulted sort of a combination trap with a fault slash pinch out up dip and sort of stratigraphic component of lateral trapping as well. So and there was this dimming that they noticed in the amplitude extraction. So this was the kind of the model that everyone took forward, whilst in Angola, the huge success rate was because you could see the hydrocarbons and the pay on seismic. I think one of the issues here has been that you can't in this particular play. The geophysics here proved to be an unreliable guide to where hydrocarbons. You could find the reservoir, but not where the hydrocarbons were. Okay, let's scoop on. Let's go on to the next one. Okay. So now we've got 27 wells. These are the countries where Jubilee analogs have been drilled up: French Guyana, Liberia, Cote d'Ivoire. We're talking here in Cote d'Ivoire, the western Tano part of Cote d'Ivoire. There have been discoveries from right up in the eastern Tano, right up against the maritime boundary. Sierra Leone, Ghana. There should actually be 28. There's a well called Savannah that isn't included. If you want to know what happened about Savannah, there's a couple of people in the audience who know about Savannah, but it doesn't look like it's another non-commercial discovery from what I understand. So there's 11 discoveries, but nothing definitively commercial as yet. So next slide. So why is that? Well, these are all the companies that drill wells in the play. Some big names, Tullow, Total, Shell, Anadarko, Lukoil, Chevron. It's not a lack of knowledge, it's not a lack of financial muscle, it's not a lack of, but everything from super majors to city-funded startups have tried their hand. We calculate the industry's now spent $3 billion on chasing Jubilee analogs outside of Ghana, with no, as yet, definitively commercial discoveries. Next slide. Just to analyze African Petroleum, I don't want to pick on them particularly, but it's interesting because they were set up specifically to explore this play. The point here is how expensive it is. They raised from city fund managers in London. This is a Frank Timmis vehicle, for those of you who follow these things will know the name. He raised $576 million to fund this vehicle that was going to explore the transform margin. They spent $198 million on seismic. I think they shot 20,000 square kilometers. They drilled 3 wells, spent $245 million on 3 wells at 100% equity. Incidentally, didn't farm anything out. Spent $85 million on G&A costs, and that's how much cash they've got left. And unfortunately, a couple of what looked like to be non-commercial discoveries to show for it. So it's an expensive, it's been an expensive journey. Next slide. So what are the keys to success? Well, I'm going to lean very heavily on the 3 key talks given at the PSGB conference that Duncan McGregor organised. Paul Daly from Cosmos, and there was a talk from Tullow and a talk from Anadarko back to back on what they'd learned. So my success factors here are drawn heavily from what these companies who drilled the most wells have said. I should also have said in that list of companies that Cosmos did not drill any wells. They were not on that list, interestingly. So the company that found, if you like, or the main driver behind Jubilee, did not drill any of these dry non-commercial wells in the follow-up, which is interesting. So first thing, what's needed to find another Jubilee? First thing, of course, is mature Cretaceous source rocks. Fortunately, in the late Cretaceous, marine source rocks are pretty widespread. And so it's a question, so you can be really reasonably confident that they're going to be there in this part of the world. So that's not the key issue. The second issue, though, is important, is the close proximity of the source rock to overlying reservoirs. So it's important to have your stratigraphic trap in close proximity to the mature source rock, so allow a migration pathway into the trap in the absence of faulting or other pathways. The third thing is a regional high to focus migration. The east of the Tano Basin is marked by a regional high, the South Tano High, and this provides a focus for migration into the stratigraphic and combination traps on its flanks. The fourth thing is the ability to predict stratigraphic traps, because although it seems that they're either stratigraphic or combination, or the faulting that may be below seismic resolution, so it may appear as a stratigraphic trap, but your ability to predict the stratigraphic trap is key. But it's been problematic because of the absence of a reliable geophysical method for predicting hydrocarbon pay in the play. As I mentioned earlier, Tullow, they indicated in 2012 that they were finding oil in thinner bedded reservoir, whilst the thick bedded sands that they could see on seismic were water wet due to a lack of up-dip seal. So success requires being able to integrate geophysics into a comprehensive geological understanding of where the pinch-out traps are possible. The final thing that's came out, struck me in the presentations at the conference, was the importance of predicting reservoir quality. In the database, of roughly half the wells failed because of poor reservoir quality, and half because of trap migration issues. So this is proving the most difficult challenge. The first well drilled, we saw Jubilee, Mahogany 1, found the thickest and best quality reservoirs of any well drilled subsequently. But we haven't been able to translate that calibration into a reliable prediction of reservoir quality. So the next slide, just elaborate a little bit about that. And this ties in a bit to Paul's talk about in drainage patterns. The hinterland geology and the scale and pattern of drainage and what's being eroded and the amount of sediment being fed through rivers to the coast, and it is one of the key issues. And they showed evidence that in Lake Cretaceous, that in the Eastern Tano Basin was tapping into the interior of Africa at the drainage pattern at that time, delivering good quality sand into the basin. The second point is the configuration of the submarine slope and its influence on the depositional processes. We'll see in the next slide that the steepness of the slope is important in terms of how much sediment how much sand you can actually stack up in any one place. If the margin's too steep, you get narrowly confined channels. And lastly, burial history, depth, temperature, and sediment diagenesis. One of the talks said that below 2.5 kilometers burial depth, reservoir quality degrades very, very quickly. So, and I'm going to quote here from the paper. This is the abstract in from the Tullow paper, and this is the quote. It said, attempting to predict reservoir quality involves building a regional geological model underpinned by sound basin modeling. I emphasize this bit. Unfortunately, time constraints imposed by the requirement to move quickly to seize opportunities often curtail this important work. Now, this is just quoting from the abstract that they wrote, but I read into that in the rush to capitalize on the Jubilee discovery, shortcuts were taken, and by implication, some unnecessary and expensive dry holes were probably drilled as a result. And there's an important lesson, I think, for us all as an industry to learn from that. Next slide. This was from the Anadarko paper, and it sort of begs the question of whether the transfer margin actually is a bit of a misnomer, because they drew the attention to this. A shear dominated margin here, the true, very steep transfer margin here, and the Eastern Tano is actually dominated by rift tectonics, and it's about 200 kilometer long slope from distance from the shelf to deep basin is about 150 kilometers, whereas here the distance from shelf to deep basin is only 40 kilometers, and this is where all the discoveries are concentrated, and exploration down here so far has been unsuccessful. So, next slide. So, some conclusions. I think the first one is that, when you see those 5 success factors, I mean, as geologists, it's not, none of that's rocket science. You think, well, actually, that makes perfect sense. But actually bringing those 5 things together in one place makes it look more and more that the Eastern Tano Basin is quite a special case. And so I'm not sure you can say it's unique, but it's certainly a special case geologically, and that's where the 2 billion barrels has been found in the play. The number of wells targeting the play in the region has dropped dramatically. It was 13 in 2012, 6 in 2013, and I suspect there'll only be a handful in 2014 targeting the play. I know Tullow I've pulled back. I know there's an appraisal well on the Payon discovery in Cote d'Ivoire, but I think that's all on the only thing on the drilling plans at the moment. And the exploration trains moved on elsewhere, notably Morocco, Mauritania, Senegal, and Ireland, where a new set of companies are trying their luck and often are citing Jubilee analogues to support and when they come to raise their funding from investors. So I think, as well as de-risking with 3D seismic, I think the message from my talk is that integrated geological models for the basins need to be created before drilling. I think that's where I'd like to stop.
Thank you very much, Keith. Yes, I think until we saw Paul Daly's lovely diagram, which confirmed that Jubilee was actually a structural stratigraphic trap, and the key up-dip element was actually a fault. It kind of made chasing amplitudes a little bit different. Now, we've got time for questions, so you can't quite sit down and get comfortable yet. So, do we have any questions from the audience? Yes, there's one there. Keith, there we go. Thank you.
My name's Steve Smith, now at JX Nippon, but while we're on the ex-BP reminiscences, I worked on those well-known turbidite fields in the West of Shetlands for the partner at the time, the Anglo-Dutch company. And I think, that, as you remarked, the Jubilee slide tells it all. In turbidites, you have to find a way to trap against the sediment deposition. Otherwise, it just goes on up to the basin margin. In the Gulf of Mexico, they're very lucky because they have a mobile salt that the turbidites come in and then can be moved around, which provides a trap that's not straight down dip from the sediment source. And the observation that some of these discoveries along the so-called transfer margin are successful with very thin sands is probably just because there are very small faults, maybe just compaction features that are providing that up-dip seal. Now, the Four Devonshire Hallion were 25 years ago? I can't remember. But they are drilled on structural noses with up-dip faults. I'm just amazed that people are still chasing plays in turbidites where they can't actually seal the up-dip.
Any comments on that?
No, I mean, I totally agree. I mean, that's
Very
the message of that's one of the key messages.
Well, one is reminded of the great buzzard lookalikes that prompted virtually the same amount of exploration. I think buzzard was seen as a 1 in 20, and that's what it turned out to be, ultimately, once we looked at all the lookalikes that had been drilled. There's a question here. Oh, wait, one second.
No. Perfect picture of linear traps on an absolutely
There you go.
monocline.
I'm not to say they don't
In the
exist,
market.
but you need a lot of supporting evidence to make you want to drill it.
Absolutely. When there were the stratigraphic traps. Yeah, DHIs can help. Right. Is there any other questions other than comments? There's one here.
Thank you. I think from a psychological point of view, I see two trends within this general kind of area. One is where there is a long series of dry holes where nothing's been found. And the investors and the companies tend to think, well, when one comes in, that will change everything. But without really understanding or thinking through why that one is going to kind of change things, because the geophysics that's been used to study the one that hypothetically does come in, it's the same technologies, the same teams, the same people as didn't find anything where they didn't find anything. And then we have the Jubilee example, which is an excellent one that you gave, where they did find something right at the beginning and then thought that there would be a series of successes afterwards, but there weren't. So we see a sort of situation where there are duds and there must be a good one which will somehow change things, and the reverse of that, where there is a good one and there's going to be good ones, but there aren't. And I think it really comes down to, as you think you rightly say, understanding the geology of these plays.
Thank you. Any other questions?
Yeah, I think it strikes, when we totted the numbers up and you come up to a number like $3 billion on exploration, it's and then you wonder why investors get a bit jaundiced about putting money into the sector. Sometimes we can be collectively can be our own worst enemy by sort of by rushing to not doing the basics.
Yes.
Well, the success rate on Frontier and Wildcats, what's it running at about 8%,
Something like that, yeah.
Yeah. 8%.
But the ones that do succeed still pay for all the ones that fail.
Oh, like
Collectively as an industry, not necessarily, but that's so not a call to stop doing frontier exploration.
No, I wouldn't want to encourage that sort of behaviour. Lots of good fun. Any other budding questions out there? Well, thank you very much, Keith. That's like a very nice...